Hello friends, welcome to Java IO tutorial. In this video, we are going to learn what is a byte array input stream. So the type here is a stream and input. That means we will read the content from byte array to byte array input stream. So you will learn byte array here, then the content will be created here in the byte array. After that, we will create a stream of this byte using the byte array stream. Then we will use a method on this byte array stream called read. So this is the sample we are going to create. This one is the text area, and then we will be having a button, and there is one more text area. So here you will type some content here, then we will click on the button read data, and whatever is the content here, that will be read and written into the second text area. So this can be easily done with the UI control itself, but here we are going to learn byte array input stream, and for that here we are representing it with a simple UI based example. Also here in this video we will learn how to use NetBeans to create this UI. So first we will learn the basics of byte array input stream. Java IO package provides a class called byte array input, and the class name is byte array input stream. There is no gap here. This completely represents the class. The color coding is wrong here. To read array of bytes, so that's the class. Its purpose is to read array of bytes. One can construct byte array input stream from byte array. So that's the meaning of this class, right? The class will read array of bytes. The read method, that means a byte array input stream, provide a method called read, and this method reads the array of bytes one by one. The return value is an integer. That means each time when you read, you will read one byte, and that byte is represented in the form of integer, and that you will get as an return value. So the read method returns an integer, and that integer is nothing but array of bytes. So the read method will return -1 when there is no content to read. Say for example, this is the byte array 1, 2, 3, 4, 5 slot. So each time the pointer will advance to the next byte to read, and at this stage it is at the last location, right? Once you read, it will return an integer, and the next attempt to read it will return -1. Why? Because it's at the end of stream. Like end of file, we can call it as end of stream. That's the technical term. We can say end of stream when the pointer is at the last location. After using the stream, we must use the close method. That means here byte array input stream, you will open this stream or construct this stream by passing the byte array. Then you will perform read by advancing the array of bytes, and after the usage you have to make a call to the stream.close method. In some situation, one may need to read from the beginning before reaching the end of stream. So for example, let's once again consider that 5 slot stuff. Each time you read a byte, the read method will return an integer. We already know that, and the pointer advances to the next. Likewise, it will advances, and let's say before reaching the end of stream. Now let's assume that you have read the content from here, and if you make a call to reset, the pointer once again go and stays here. So that's the usage of reset method, but it is used rarely. Mostly people will use the read method, and after reading the stream they will close. Now let's start an example and make use of byte array input stream. So here, if you see, we have only one button right in the UI, btn read data action performed. So this is the UI we are going to construct. When we go to the demo, that time you will see how to create this UI. And TA input. So this is the TA input. And from TA input we are making call. TA input is nothing but JText area. From JText area we are making call to get text. So this will return the text and we are storing that in a string. Then from the str data we make a call to get bytes. This will give an byte array. So this is the byte of data. Next, we construct our byte array input stream by supplying this array of bytes. So if you see here, user will type some content. From this content we make a call to get text, and from that string we construct the byte array. So here we will be having the byte code, and we construct a byte array input stream. Once the stream is created, we can use the methods that present in this stream to read this content. So here if you see, we are having int char data, we just declared it, then we have a string text. Here if you see, we are forming a while loop. Notice the open bracket. This is one and this is the other one. Alright, here if you see byte in stream, that's what we constructed here, byte in stream, and we are making use of the read method. We know that read method will return an integer and we are storing that here, and at the same time we are checking whether the return value is -1 or not. So if it is -1, that means we reached the end of the stream. So that means if it is not equal to 1, we will enter inside, otherwise we will come out, because there is nothing to read and we come out of the loop, meaning that we read all the content. We read all the content means the content which is formed here, right? Now let's look at actual stream. That means here we commented it, and say for example we have a text, right, string text. We are directly making use of this char data because it returns an integer, right, and we are appending that integer and we are appending that to the text. On each loop we are appending the integer data here. So first time we will run the code with this one, Snippet 3.4, and see what is the, or how the raw data will look when we use the byte array input stream. And in the latter case, if you see, the same piece of code, but here we typecasted that integer to a character to represent that char data. Whatever we are reading, it's an integer representation, right? We are converting it to a character, then we are appending it to the text. Then we are setting the, then we are making call to set text, and here we are placing the content. So we will experiment both. Here it's a raw data, and here it is converted into the char form. So our example goes like that. Say in NetBeans, we will first construct the UI after creating the project. Then we will handle the action performed event and we will write this piece of code. That's how our example will flow. Alright, now it's demo time. We will go to the demo. Just now we opened the NetBeans IDE. Now we will create a new class. New. This time here we are creating the JFrame. So in NetBeans you can create a JFrame and you can directly run that JFrame. So that's the step. Right click on the package name, then click on new JFrame form, and here we will name this as ADV003 underscore ByteArrayInputStream example. Here I am clicking finish and you can see NetBeans loads the form initially and it will land you in the design view. So you can alternate between design view and the source view. So I think it requires more cleanup. Let's leave it as it is. And here whatever I presented in the PowerPoint that I kept here, and let's see how to design this form. So first JFrame, and if you see here we are having the JFrame. Let's expand it, and the JFrame contains nothing. First we have to add two scroll pan, J scroll pan 1 that will be here, J scroll pan 2 here, and inside the scroll pan we will be adding the J text area here and here. Alright, first we will do that, and now we are concentrating on this portion. First we will do this. So J scroll pan name is default, and here if you see swing container scroll pan, and when I place the mouse cursor it reads the class name also. You can see javax.swing.jscrollpan. Press down your mouse button, drag, and you will see the icon with a rectangle below the arrow key. And once it comes out of that palette, I mean the control palette, this portion, you will see a big square, and go inside the form and place the first JScrollPan. And here we resized it to match the width. That's all. JScrollPan is ready, and we will put one more JScrollPan that will be in the bottom. So the second JScrollPan also ready. Now we know that in the previous Java Swing series we wrote everything by hand. That means we doesn't use any form based UI like this, and we created the JScrollPan. So we know that JScrollPan can take any component and can provide scrolling support for it. If you create a panel with multiple controls in it, and if you place that inside this JScrollPan, you can scroll the content of the JScrollPan with multiple components in it. If you place some component like the JText area inside this scrollpan, the JScrollPan provides scrolling support for the JText area, because the JText area can expand width and height wise, right? It can support n number of characters in a row, and it can support typing multiple lines of text. Now we have two containers here. We will collapse this container, and The same way, we will click here, drag and drop the text area, and you can see it occupies the entire area here. Then the same way, drag and drop the text area in the next container, and you can see JScrollPan1, JTextArea1, JScrollPan2, which contains JTextArea2. Now let's go back to the Paint, and here if you see, we have to rename the control name. This is the control type, JTextArea, and this one is the control name, TA input, TA output, text area input, text area output. Now we will go here, right click, change variable name, TA input. Okay, so that's one way of changing the variable name. Now we will change the second variable name. This time we will change it differently. Here I select, you can directly select the control name here, and you can see it got highlighted here. Right click on the control name and change variable name here itself. So TAOUT put T output. So we rename the controls, text area controls. Then we will change the name of our button here. So here we have to change the name as well as the display name. Display name here is read data. Alright, first we will go to the J button. The tooltip shows javax.swing.j button. Move that and place it here somewhere. Then change variable name btn read data. So that's the control name. After that we have to edit the text. Text is read data. So that's all, our JFrame is ready. Now we can start writing the code. So click on this read data. Here if you see, you have properties, binding, events. You have to click on the events. Then action performed, right click and accept the default method name. So here just by scrolling you can see it got highlighted. So this is where we have to write our code. So you may wonder where is the registration, all the stuff, and it will be there in the generated code. If you expand it, you may see btn action performed and how it was written. So this is why initially here you can see public void action performed, and the inside this handler the generated code is making call to the btn read data action performed method, and it passes that EVT. Right, so you no need to worry about that. So handler is provided and you have to start writing the code. And if you watched our previous swing series, and you can easily understand why, because everything you hand coded, and just by looking at the code you will simply understand that here add action listener and new AWT event action listener. That means this is an anonymous inner class. Inside the anonymous inner class there is a method, and inside the method we call custom method, and for the custom method the generated code is applying the action event. So that way you can understand the generated code as well. If you learned AWT and swing, and if you haven't used any form designer like this, that's the benefit. Why? Because you handwritten everything. And if you directly go through the design like this, it will save a lot of time, and you can design the UI in a quick manner and start writing the code. That's the advantage here. And the flip side is, if you want to add some component dynamically, then the design stuff won't work. So that's why you have to know how to create component at runtime and how to hook the event at runtime, all those stuff. Alright, now let's go ahead and start writing the code. So here inside, we are reading the data from text area input, and we are converting it as a byte. Then we create ByteArrayInputStream. So we have to import it from java.io. So in the slide we talked about, right? So this is not NIO and this is java.io package. That means this class exists in legacy version of Java also. That means if you go to Java 1.2, the old version, you can still see this ByteArrayInputStream. So we imported that class. Then we form our while loop. So we already saw this in the PowerPoint slide. Here if you see ByteArrayInputStream, so this is the open bracket, right? Here we read the content and return value, we are storing it in the char data integer. And at the same time in the outer, we are checking we haven't yet reached the end of string. So if that's the case, then we will enter inside. Next, we append this char data content to the text, and here is the text, and we append that text in the TA output. Instead of append, we can go ahead with setText method. Now here if you see, we are just learning this ByteArray stream input stream, right? So we can directly run this. Before that we will compile. Here we kept all our example under single project, so when you go for a build, clean build, it will compile the previous two files also, but that's okay. Now right click this and say run file. So it presents our UI. And here we are making call to read data, and you can see the data is read in the form of array of characters. So this is what called stream. And now let's go to our design. This is the scroll pane, right? Properties. So we just selected the scroll pane, horizontal scroll bar, never. So we saw the stream is in a single line, right? So this one is TA input. Anyhow, here we are formatting it, no issue. Here we are writing it and we are dynamically adding the content. TA output, and we will Boolean property, should lines be wrapped. There is weight wrap also. Okay, we will go with the line wrap. We will run this once again. Okay, here we cannot run it directly. We'll compile, or you can compile the specific file also. After that you can run that file. Now we are reading the data and you can see the byte array. From here we are constructing the byte array, right? So this is the raw data which is shown here in the bottom of the text area. Now we'll go to the source, and this is where we have written our code, right? And we will just typecast this raw data to the character form. And now we will compile this. And we will run this file. So we have written some data in the input. Now we will read the data, and you can see, since we converted it as a character, you are seeing how the byte stream is processed. So in actual world, the stream of data, this byte input stream, can come from different media as parameter. So you will actually end up writing this piece of processing code. Alright.